Perhaps you have heard tons about coding, however, you may not have much more than this vague understanding of the concept. To put it very simply, the code is what tells your computer what to do. To go a bit deeper, computers don't understand words. They only understand the concepts of on and off. The capabilities of a computer are guided by on and off switches or transistors. Binary code represents these on and off transistors as the digits 1 and 0. An infinite number of combinations of these codes make your computer work. In order to make binary code manageable, computer programming languages were formed. These languages each serve different purposes, but they all allow programmers to translate important commands into binary code. The C# compiler compiles the C# source code into the module, which is finally converted into the assembly code. The assembly contains the intermediate language code along with the metadata information about the assembly. Metadata is data that provides information about other data. In other words, it is data about data. So the code written by the human is converted into intermediate language code, and the metadata of this intermediate language code. .NET provides a runtime environment, called the Common Language Runtime. Once code gets compiled using any of the .NET compliant language compilers, it gets converted to EL, intermediate language, as seen from the above diagram. This code is not compiled to machine-native code but to an intermediate form which doesn't contain any specific information about hardware nor software dependencies. When you run this code, since it is not in machine-specific form, it fails to execute. So, in order to make EL code converted to machine-specific code, there must be a runtime environment, which understands and converts the EL code to machine-specific code. The EL code is stored in the executable. When you run the program, the .NET JIT compiler reads your EL code and produces an executable application in memory. The intermediate code is converted into machine language only when the application needs it. The JIT doesn't necessarily compile all the EL code into machine code at once. If the function has blocks that are not entered, they will not compile until execution actually passes through that block. The code gets converted to electronic signals and sent to microchips. The circuits in a computer processor are made up of billions of transistors. A transistor is a tiny switch that is activated by the electronic signals it receives. The digits 1 and 0 used in binary reflect the on/off states of a transistor. All software, music, documents, and any other information that is processed by a computer is also stored using binary. Afterwards, the binary 1s and 0s can be converted to different type of data such as numbers, letters, sounds, and many more. This video you are watching on your display right now is a view of the underlying voltages residing on memory. Each pixel on the screen and each sound you hear from your speakers are coded 0s and 1s, constantly being converted into different type of voltages being shuffled around every nanosecond. Don't forget to like and subscribe.